All right, I'm going to try to tackle number 3, number 4, and number 9 in one video. Hopefully it won't be too lengthy. They all have the same setup. They all have a power source going to a single resistor that's in series with two other resistors that are in parallel, and then back to the power source again. So for number 3, we're given 3 volts, 1 amp going from the battery out into the circuit. This first resistor has a 1 ohm resistance, and both in parallel have a 6 and 3 ohm resistance to them. And we want to find out the voltage across this guy here. All right, so a very quick way to do this is to recognize that there's 3 volts total, and that the voltage across this one resistor here is 1 amp. And where does that come from? So the voltage for this guy here would be its IR, and going through this resistance is 1 amp, and it has a resistance of 1 ohm. And so we see that it's a 1 volt going across this resistor. Now we know that both of these two have the same voltage, and it needs to be the rest of the voltage that adds up to 3. So we have the total. We take away this voltage of 1, that leaves us with 2 volts, and so we should find 2 volts to be around across both of these resistors. Another way to do it, a little bit more lengthy of a process, is we could find out what the total resistance is to those two in parallel. And so we take the 1/6 and the 1/3, we get a 1/2. You flip that over, and we find that the parallel resistance is 2 ohms. And once again, we have 1 amp of current going through that effective 2 ohms, and our V equals 1 times 2, again, getting us that 2 value that we had already found. Now moving on to the next problem, number 4, that has the same look to it. So we want to know what the current is going through the resistor. We want to know what the parallel resistance is. That's an additional question that's not on your paper. I'm adding that. And also I want to know what the voltage is across these resistors in parallel. Again, that's not on your worksheet either. I'm adding that, just why not? Okay, so here we see that one way to do this parallel branch and figure out the total amount of current going through it would be to use the proportionality trick. And we see that like 8 is 2/3 of 12, adding these two together, which means that we'll get 1/3 of the current. And 4 is 1/3 of 12, so it should get 2/3 of the current. All right. So with that said, if 2 amps is going through the 8 ohm resistor, and that's 1/3 of the total voltage going through this parallel branch, well then we can see that 6 amps would be the total amount of current going through that parallel branch, which means there must be 4 amps going down that branch there. Another way to do it, we could have found out the voltage across the 8 ohm resistor, since we do have its current and its resistance. So the voltage across this guy would be IR 2 times 8, which is 16. Being in parallel, this has the same voltage of 16. And if we divide it by the R, we can get the 4 amps value to the current. And once again, like, you're being asked to find out what the current is through this resistor here, right? But what's going through it split up into the parallel branches, right? So 6 amps went through this resistor before getting to the parallel branches and splitting off into 4 and 2 amps respectively. To find the parallel resistance, we use the parallel rule, 1/1/, flip it over, and we see that we get 8/3 ohms as the resistance there. And by the way, I did solve for number 3 already right here using the current and resistance along this branch here, we know what the voltage is about the entire parallel part of that circuit. You know what? We're just going to do 3 and 4. I'll do 9 next.